Hey everybody, welcome to Bill Sky, the Assembly Guy. We're going to be introducing you to assembler language in this course, and what we're going to do today is just go over what's it all about. What are the reasons why computer science majors need to understand assembler language, and what's it good for? So the first thing that assembler language is it's the lowest level programming language you can use to program a computer. I mean, other than ones and zeros, other than machine code, other than knowing that, which we used to have to do years ago. So it is the lowest level language, which makes it a very useful language at understanding how the CPU works. Also is directly related to machine code. And that's kind of what I said a moment ago, is that every statement in assembler language is directly translatable into actual ones and zeros. Unlike a compiler does more than just translate your code into machine code. It actually does optimization. It does a lot of different things that an assembler does not do. So an assembler is different than a compiler in that way. An assembler is mainly just a word-for-word translator, where a compiler is more of an interpreter. What did they mean by that? Was the grammar correct? Also, without assembler language, writing compilers, interpreters, device drivers, operating systems would really be difficult. For those of you who don't know what a device driver is, every time you connect a piece of hardware to your computer, the operating system has to know how to talk to that. It has to know what the language of that device is. And that's what a device driver is. So that's partly what it's used for. It's used for things like device drivers, operating systems. It allows you to translate it. It's a translator between the human thought and the CPU's languages of ones and zeros. Compilers are like add yet another level to that. So you really have to know how the CPU works when you use an assembler. Where with a compiler, you don't really have to know how the CPU works. And all of you that have used Java, which is not compiled, it's tokenized, but languages like C or C++, even COBOL, Fortran, those languages, those are compilers, and you really don't care how the CPU works. It is generated, assembler code is generated by many compilers, and then that compiler will then call the operating system's assembler to then convert it into the ones and zeros. Assembler language programs can very easily communicate or talk to connected hardware. And in some cases, that's the only way to talk to that hardware, is using assembler language code, because it doesn't have a higher level language set of libraries or interfaces. And if done correctly, it's important to say that, if done correctly, it can generate some really fast, efficient program code. So it's used quite often for that. A super fast sort or a super fast search, something like that, it could be used for. And the thing that I'm the most concerned about as a teacher is that it shows the inner workings. It shows the inner workings of the CPU and the computer. So as a computer science graduate, I mean, even if you're not a computer science graduate, but it really helps you understand the complexities of the CPU, where just a language like C or C++ doesn't. You're just learning the language itself. So what are we going to do in this course? I'm going to show you how to code an assembler language using Windows, Visual Studio specifically, using Linux. We're going to use Mint Linux or any kind of a Debian, however you pronounce it, Linux. So we're going to show you how to do it in that as well. And we might even do it in ARM computers like Raspberry Pis. So, and also maybe even Apple Mac M1 or M2s. So we'll see how far we get, but that's the intention here. I'll also show you how to do this, almost all of it, on a single computer. So you don't have to buy multiple computers. I'll show you how to how to do this using virtualization tools like VMware VirtualBox, Hyper-V, and maybe even a couple of others if we have some time. So I believe you're going to have a lot of fun learning. I promise you it's going to be a lot of fun. I love to teach, as my intro to me said, and it's true. I absolutely love to teach. And now that I'm a retired college professor, I've got the time to really produce some nice videos and help just about everybody. So let's get started, and I'll see you at the next video.